Hi everybody, it's Linda Jackson here from Food Focus. I trust that you can all hear me. If we've got any problems with sound, please won't someone give us a shout out by using the chat bar. I know that I've got Adele sitting in France, making sure that we've got quality control happening. So I'm sure Adele will let us know if there's a problem on her side, but anyone else, please won't you just shout if there is a problem in that regard. Please can you just check that it's your, you haven't muted your sound coming in, your speakers coming into your computer, so that you should be able to hear us. Okay, I'm going to get straight into it, making sure that you're comfortable. I hope you've got a cup of coffee. I'm really excited about the presentation that we're going to be hearing. So while we wait for a few more people to join us, I'm just going to go through some housekeeping rules. Please make sure that you are using your speakers on your computer. We're not going to be able to take a telephone connection for this particular webinar rather. If you can see the bar, or if the screen is too small, there's a maximize button for you to be able to see the full screen. You should be able to see the full screen at the moment, and at the end you'll obviously click on the restore to go back to the normal view. Just in terms of questions and chatting, we'd like this to be interactive if possible. So there are two options for you to use. If you have any concerns or any queries regarding the process of the webinar, you will see a chat bar. Please won't you communicate with us using this chat bar. You're just going to send me a message and I'll see it pop up on my screen. If you have any questions, there's actually a Q&A section or a question section, and you can type your question in there, and we will answer those questions at the end of Shane's presentation today. What we're also going to do is, this is a fantastic presentation. I'm so excited about it. We will be converting this into an article which will be going out on our website, courtesy of Food Consulting Services. So if there are any questions that we don't manage to answer before the end of the scheduled broadcast, we will definitely answer those in our article. And then we are recording the webinar, we're live, and so you'll get that within a week of this presentation. I think we're ready to go. So it now gives me great pleasure to hand over to Shane Rimmel. And Shane is from Food Consulting Services. Let me tell you a little bit about him. He's a through and through microbiologist. He knows all these bugs on a first name basis. He completed his BSc microbiology at WITS. He's also got a BCom and a risk management diploma. He started working for Food Consulting Services in 1996. And as the business has gone on, he's become a shareholder and a director, and he's been involved in the amazing transformation of FCS from a complement of staff of 7 to its current staff complement of over 35. So great growth in this business. He's also was instrumental in assisting FCS in becoming one of the first microbiological laboratories in South Africa to receive 17025 accreditation. And he's worked in both the chemistry and the micro lab. He's got over 23 years experience in just food testing and consulting. So I think it's definitely the right person to talk to us about what to do when I have a problem with my micro results. So welcome, Shane, and thank you so much for your time. We're really looking forward to your presentation. I'm going to hand it over to you now.
Thank you, Linda. Thank you very much for the opportunity to do this presentation and this webinar. So we're going to jump right into it. And first of all, I just wanted to discuss what is a positive result. So usually a positive result would be associated with a positive pathogen result, but I would like to extend that to also include positive results relating to food spoilage microorganisms as well. So on the first slide, I've said a positive result is defined as any result that does not comply to specifications. So first up, we'll obviously have the legal specifications that we know we need to comply to. That would be country specific. There are also guideline specifications available from, for example, Codex, which have a comprehensive guide of all the microbiological specifications for food. So if there isn't a legal specification available, it is always a good idea to refer to Codex to understand what do they recommend in terms of guidelines and specifications for microbiology. You might have even in-house or client-specific specifications, Very often, if you sell or manufacture food for various large corporations, they may have their own specifications that may or may not even be stricter than legal or guideline specifications. If that is the case, you would usually have an agreement to comply to those specifications, and it is your obligation then to comply to those in order to ensure that you are able to sell your food to your clients. So a positive result really means that it does not comply to any one of those specifications. And in terms of the microbiological testing, as I said, I'd like to split it into two main sections. I'd like to include food spoilage microorganisms because these decrease the shelf life of food. It causes the food to spoil or go off, which is very important because you don't want your food spoiling out on the shelves, causing problems. The other section would be your food poisoning bacteria or pathogenic microorganisms. These are the bacteria that are causing food poisoning, and they may cause people who consume the food to fall ill or even die. So talking about the food spoilage microorganisms, we're generally talking about general bacteria, yeast, and molds. You would usually have the standard play count or total microbial activity. These are usually abbreviated to SPC or TMA. That is testing for the total number of microorganisms in the product. You can also test specifically for yeasts and molds. Molds are a common food spoilage microorganism. Also, lactobacillus and lactic acid bacteria may also cause certain products to go off or even blow, which is a problem, especially in sauces, as well as various other vacuum-packed products. So the food spoilage microorganisms may not necessarily cause food poisoning, but they can cause the food to look off, so usually slimy, moldy, or a bad odor. They can smell off, taste off. Microorganisms also produce gas and can cause the food to blow. So it's for these reasons that we don't want to have out of specification results for the food spoilage microorganisms, and it's something that we need to attend to. If you have high levels of food spoilage microorganisms in your food, you could have economic losses due to poor perception of the food by the consumers. So when you're buying your food in store, if it's looking off or smelling off, consumers are not going to buy that food, and they may have a negative attitude towards your brand or product. Obviously, there are also product recalls. If there are issues in the trade, you may have to recall your products. This results in lost sales and ultimately lost trust in the public. And trust is something that we really need to try and build with the public that are purchasing our food. Going on to the food poisoning microorganisms or pathogens, these are mostly bacteria such as Salmonella, E. coli, Staphylococcus aureus, Bacillus cereus, Listeria monocytogenes, Campylobacter, etc. So here the food doesn't usually smell or taste off or look off. So we can't use our senses to defend ourselves. And this is the problem with food poisoning microorganisms, is that we don't know that they are present. When we're looking at the food spoilage microorganisms, obviously it's easy, or generally easy, to tell whether food is off or unsuitable for consumption. But when it comes to the food poisoning or pathogenic microorganisms, we don't know whether they are present or not unless the food is tested for. And again, we can have economic losses due to legal action. So consumers that have died or have fallen ill may sue the company. Obviously, again, poor perception of the food by the consumers. So people hear about the food causing illness and they'll stay away from it. Obviously, there's product recalls and again, lost sales and ultimately the lost trust, which is difficult to win back. So very important that we have a look at these food poisoning microorganisms and what to do about them. So if we do get a positive result on a batch of food, I think the very first thing is to try and determine how big the problem is. So what is the extent of the problem? And I think what we need to have a look at here is examining any existing microbiological results. So if you're testing regularly for microorganisms in your food, let's have a look at some of the results in the past, see if we can pick up any trends. We must physically examine the foods. So are they blowing off? Are they showing any signs of spoilage? When it comes to the food spoilage microorganisms, often you might have certain products in a batch blowing, or certain batches blowing or looking off. We would recommend that you test additional samples from the same batch to determine the extent of the problem. So is it sporadic, or is it the entire batch? So if you get a positive result, is it every single sample in that batch that is affected, or are we looking at only sporadic samples within a batch being affected? We would also recommend testing the batches immediately before and after the affected batch to see if we can't pick up a trend or a problem that started, and try and understand when did it start. Was it with that particular batch? Was it a few batches before? And again, these additional tests will help us to ascertain how big is the problem. Once we can understand what we're dealing with, whether it's just one batch or if it's multiple batches or just a few products within one batch, again, it'll help us to investigate where the problem lies, and will also enable us to determine the appropriate course of action. So before we launch into trying to find out what the positive result means and how to fix it, I think we need to just deal quickly with what must be done with the affected batch. So if we find one batch or two batches that are effective, what are we going to do? So if we have pathogens or food poisoning bacteria detected before the distribution of food, the obvious thing is not to release the food and then destroy the food correctly, unless it is possible to treat the food to make it safe or to use as a rework. Now, this is a bit tricky. Sometimes there are methods or processes available that will help you to destroy the pathogen, that you may be able to still sell the food or to rework the food, again, depending on the type of food that we're dealing with. But you're going to have to do a cost-benefits analysis and understand, is the quality of the food going to be affected by reworking it or treating it? And what is the probability of the eradication of the positive results with the rework? So is there a chance that this bacteria is still going to be present after you do what you would like to do to the food to try and make it safe? In many of the cases, it may not be worth it. It may not be worth the risk, and it may not be worth the cost. And the best and safest route would still be to destroy the food. However, it is not the only solution, and reworks or retreatment can work depending again on the type of food and environment that you're working in. If the pathogen is present and detected after the distribution of the food, we would recommend obviously of recalling the food immediately and then destroying the food correctly. And when we talk about destroying the food correctly, it must be done using the appropriate destruction methods and companies. You can't just throw it away into the waste, because it might turn up somewhere down the line with people trying to eat it and make them sick. So we move on now to what must be done with affected batch if we have high levels of food spoilage microorganisms. So if there are out of specification food spoilage microorganisms present before the distribution of food, so before it's left the factory, so for example, a high standard plate count or yeast and mold, we've got to ask ourselves, can anything be done to reduce the level? Can we use heat treatments or possibly lower the pH, or could we possibly add additional preservatives to that particular batch to try and lower the food spoilage microorganisms? And again, it's going to be a cost benefits analysis. So what is the cost to do this? What is the benefits? Is it going to affect the quality of the food? Because again, if you are reducing the food spoilage microorganisms, but ultimately altering the quality of your food, it may not be worth sending that food out into the marketplace. Even though it's safe to eat, the quality may have been affected, so that consumers do not want to use the food anyway. So if the costs or the risk of improvement is too high, it may again be best just to destroy the batch. If there are other specifications of food spoilage microorganisms after the distribution of the food, so for example, again, high standard plate counts or yeast and molds, again, what you're going to have to look at is what is the risk of the product spoiling before the end of the shelf life. So what is the level or how far out of specification is the total plate counts or yeast and molds, and what is the risk of this product running out of shelf life while still on the shelf? If there is a higher risk, again, it would be the best to recall the product, because you don't want the product going off or looking off or tasting off on the shelf, because for the previous reasons mentioned, it's going to cause you problems in terms of economic losses and loss of trust. If there's a good chance of the food reaching expiry without spoiling, so if we've just got a slightly out of specification standard play count or yeast and mold, and the risk is very low that the product is going to spoil on the shelf, it may be acceptable to leave it on the shelf. But again, it would be wise to do a cost-benefit analysis and have a look at the risks. So in conclusion, in terms of the affected batches, usually the best course of action would be just to recall or stop the product from going out of your factory and then to destroy the batch. But in certain cases, depending on the types of foods, microorganisms, etc., it may be you may be able to treat or rework the food to still make it saleable. So now we need to determine, once we have the positive results in a batch of food, why has this happened? So in trying to understand why it has happened, we need to try and understand what caused the positive result. And in order to do this, we need to understand the main potential causes of a positive result. So what I'm going to run through now is, in my experience in the last 22, 23 years of visiting food factories that have had positive results, out of line results, and trying to help them solve these problems. These are the main reasons why products have failed in my experience. The first would be the failure to identify a critical control point. So it is very important that you have analyzed your food process and that you're able to correctly identify the critical control point. If you by mistake leave out a critical control point, this would then affect the quality of the product in terms of the microorganisms and cause problems. So when we're trying to find out what caused the issue, again, make sure that we have identified each critical control point and maybe have a relook at your entire process. The next area would be the failure of an identified critical control point. So even though you've identified the critical control point, it has still failed. Sometimes this failure is not picked up for whatever reason. Only after investigation, it is found out, yes, the critical control point did fail. Hence, it has not reduced the bacteria to an acceptable level. And that is the reason why the products have now got a positive result. The third area we will now look at is unhygienic practices or incorrect handling of food after the critical control point. So remember that your critical control point is there to reduce the bacteria levels or eliminate the bacteria altogether. After the critical control point, it is very, very important to make sure that the food is hygienically handled. If we implement a critical control point, it reduces the bacteria to the correct levels, but then we do something after that to cause the product to be recontaminated, we are going to get positive results. So, for example, if a product goes through a cooking process for the correct time and for the correct temperature, it comes out of the cooking process, the bacteria have been reduced to the correct level. If we then have another process, such as a cooling process, which is not controlled properly, it may recontaminate the product. The fourth one, and possibly one of the most common, is ineffective cleaning and sanitizing. Now, this is really just getting down to basics. I find very often in factories, there's so much paperwork and ticks and checks and so on to do that people just forget about what are the actual basics of cleaning and sanitizing. Making sure that you have the correct chemicals, making sure that you have the correct procedures, the incorrect chemical types, problematic chemical manufacturers, which are not registered with the National Regulator for Compulsory Specification, and then also incorrect cleaning frequencies. So it's important to have a look at your cleaning program, make sure that you are engaging with your chemical supplier, understanding that you do have the right chemicals for the correct cleaning and sanitizing applications, and then very important to make sure that those chemicals are correctly diluted. If they're not diluted correctly, they will not be able to perform their function correctly. And then they must be applied correctly as well. Once they've been correctly diluted and applied, we should receive the desired results of reducing the bacterial counts in the factory. The next one I want to chat about is poor understanding of CIP, or clean in place systems. Very often we go to factories, specifically sauce manufacturers, which have a cooking pot where they cook the sauce. It then gets distributed via pipe work, and they feel that if they are now heating up some water with a detergent solution and flushing it through the pipes, that is a CIP system. That is not a CIP system. A true CIP system is a system where you have sufficient pressure, sufficient temperature, and the correct chemicals that are pumped around the system to eliminate the product, and to also clean and sanitize and eliminate biofilms. If you're just using your normal pumps and systems to move the detergents and sanitizers through your food factory, that is not a dedicated CIP system. So it's very important to understand whether you have a true CIP system or whether you're just utilizing your normal pumps and systems. If you don't have a true CIP system, you're going to have to dismantle your plants and clean and sanitize, which we'll talk about a little bit more later. The poor cleaning and sanitizing will generally lead to biofilm buildup. So these biofilms are really slimes or collections of bacteria and other microorganisms that build up in pipes in various sections of the factory where the food is flowing through. As they build up, they start to break off, and they can enter the food and eventually into the products, which are going to cause positive results. So intermittent and erratic microbiological problems are usually an indication of biofilm buildup in the factory. So if you test your product and it's not the entire batch that's affected, but only a certain percentage of the products and very erratic, it's because the biofilms are breaking off, getting into the food, and only entering certain of your products, causing them to blow or to have a positive pathogen result. So poor cleaning and sanitizing, lack of CIP is one of the main issues in terms of positive results. So getting back to basics, understanding cleaning and sanitizing, and putting an effective system in place is one of the most common problems, and one of the, also again, a fairly easy solution to fix. The other thing I want to chat about is the poor design of plants or equipment. Often we'll go to a food factory and we'll find dead ends that are building up biofilm and bacteria. There are dead spots within the system where food is stagnating too long, poor welding, poor joints. It's very important to make sure that the entire food process, whatever equipment is being used, is correctly designed. The main thing we want to avoid is any kind of dead spots or dead ends in the system, because if the product is able to stand for a certain time, the bacteria then have the opportunity to grow to the high levels, which are going to cause a positive result. And then again, just the design of the plants. Often you go and you find these spot welds that are very rough. Remember, bacteria within the system also need to cling to or find a place or a home in the system. And the rougher the weld, the rougher the surfaces, the easier the bacteria can adhere and ultimately grow and cause positive results. So it's a good idea to have a look at your entire system and make sure that that the actual surfaces and the equipment that is being used is correctly designed to try and prevent the growth of the bacteria. The other thing is the poor design of production processes. So again, having a look at your process, often we found that you have an entire system where there is nobody handling the food except, so no humans handling the food except after a CCP, where there's a brief handling of the food by people. So again, when you have people introduced into the system, there's variability. So again, that system should have been designed to eliminate people completely from the system, so that the food never touches anybody's hands or is not carried or handled by anybody. So what I'm trying to say is, again, it's going to be very unique to the food production plant that you have, but try and design the food production process as efficiently as possible, and have a look at possible areas where contamination could be coming into the system. It might be a drain flowing in the incorrect manner from a low risk to a high risk, where it should be flying from a high risk to a low risk, because you don't want bacteria coming from a low risk area with high numbers of bacteria into a high risk area with low numbers of bacteria. So have a look at your entire system and make sure that your process is designed correctly. The other area we need to have a look at is poor maintenance, and this is often an area that can be improved in food factories. Obviously, there are budgets and capex allowances that need to be considered, but if your factory is not well maintained and there's lots of cracks and nooks and crannies, broken equipment, pipes that have got cracks where product is oozing out of, it's going to make it very, very difficult to have a clean and effective factory. So ensure that your maintenance program is up to date. Have a look at your entire process and make sure that it is well maintained. Another area could be poor staff hygiene. So very often you have staff themselves bringing the bacteria into the facility, and we'll talk a little bit more about how we're going to prevent that. And then lastly, we're looking at supplier or ingredient problems. So we may be using a supplier which is causing problems, or providing raw materials which are contaminated and making it difficult for us to eliminate that contamination and ultimately provide a safe final product. So these, in my experience, are the main causes of positive results or out of line results in the factory. So what can we do? If we get a positive result, what are we going to do? So we're going to need to examine the entire food production process, from the receipt of raw materials to the delivery of the final product, and try and determine if there are any problems in the system. So using those categories that I've chatted to before, let's go through the entire food production process and try and tick off, have we identified our CCPs? Have we, are the CCPs passing? Have we got the correct chemicals? Are our staff controlled correctly? Are they washing their hands effectively? Is our plant well maintained? So run through it in a systematic way and make sure that we have covered all the bases. So we're going to use the knowledge of the main causes of the positive results and identify these problems. If you're having an issue with this, it may be a good idea to call in an external consultant with a fresh pair of eyes and ideas. Very often working in the same environment day after day, year after year, can cause what we call factory blindness. And where you see something that's a problem, you become used to that problem, and the problem has now become the norm, and it is difficult to see it. So if you are having problems or difficulty identifying or finding out where these problems are, it is a good idea to call in an external consultant. So what can we do? Once we've identified the potential problem areas, additional microbiological testing may be required to determine if these areas are indeed problematic. So we're just going to run through the various sections and just chat a little bit about each one. So in terms of a failure of a critical control point, test the foods before and after the CCP to determine if the bacterial numbers or pathogens are adequately reduced or eliminated. So in your food production process, just before the foods go through the CCP or the final CCP, take the foods off the line, test them, see what we're getting. Are we getting positive pathogen results? Are we getting high bacterial counts? Let them then run through the critical control points and test them afterwards. We can compare the before and the after and make sure that we are indeed having the reduction of pathogens in general bacteria. A CCP not identified, once you've been through the system and you've identified the CCP, again, implement a test before and after the new critical control points, and again, ensure that you're getting adequate bacterial reduction. Poor handling after a CCP. So what we would recommend here is to test the foods immediately after your critical control point. So let's say, for example, we have a cooking process in the production. As those samples come out of that cooking process, again, making sure that they've been cooked for the correct temperature and time, take them straight off the line, test them, see what the bacterial numbers are, and compare that with the final packaged product. Again, if we've got a very big variance in terms of bacterial numbers or pathogens, you can know that somewhere along the line, after the CCP, up until packaging, we have our problem and we can focus in that area. All right, in terms of cleaning problems, the best way to do this is to try and dismantle as far as possible your entire food production system. So dismantle parts of the plant that are not often cleaned or not part of the true CIP system. Again, the true CIP system, as I've said before, you need a proper, separate, professionally designed clean in place system This is not just normal pumps or just trying to pump through some detergents and sanitizers using your normal pumps and systems. The CCP has to be designed by a professional expert company that can ensure that we've got the right pressure and the right temperature with the addition of the correct chemicals, or else you're not going to be getting effective cleaning. So dismantle that part of the plant that is not often cleaned or not part of the true CIP system. Then swab these and examine these parts. Often these areas may be visually contaminated with biofilm buildup, and pay special attention to flexible hoses. So in my experience, going into a factory, having a look, we might find a very long pipe that has got many turns in it, and there's no way to dismantle that pipe. We've been into factories where we ask them to angle grind, cut the actual pipe. We then have a look inside the pipe. In that pipe, we see the actual biofilm buildup. Put your hand in, you're going to find it to be slimy. Sometimes it can even be dark in color, and you can actually visibly see the contamination. Flexible hoses, very often in a food production plant, most of the equipment would be stainless steel, but here and there, very often on packaging machines, there are these flexible type hoses, usually made out of rubber or a similar compound, and these, in my experience, are very high risk. They're not replaced often enough, and again, remember, these the rubber starts to perish, little cracks start to form. Bacteria can adhere to these areas more easily than the stainless steel, and they then have the opportunity to grab hold and grow into biofilms. I've been to many plants where they've said that the packaging machine is properly CIP'd. Again, remember, if it's pumping a chemical through the packaging machine and then through the spout right at the end and just spraying it out, it's not going to build up enough pressure. So that last bit of the packaging machine that is not involved in a loop of a CIP is not going to be a part of a true CIP system. And those nozzles and pipes must be dismantled regularly and then cleaned and sanitized manually, scrubbed out and soaked in a proper sanitizer. So by examining all of the parts of the plant, we will often find visible contamination. We can take swabs of the visible contamination to confirm it, but I would also recommend, even if there isn't visible contamination, to take swabs of these hard to reach areas or parts of the plant that are not often cleaned, send them away for testing, and then evaluate those results and make sure that the bacterial numbers are low or within specification. So poor plant design, again, look for parts of the plant with rough welds, hard to reach areas, rough joins, or areas which could harbor bacteria. Remember what you're trying to do here. If you can imagine trying to look for somebody that's lost in a desert. If it's an open desert with flat land, no mountains, you're flying over in a helicopter, it's going to be very easy to spot that person. But if you now trying to find that same person in a very mountainous area with caves and trees, it's easy for that person to hide in a cave, be under a tree, within a valley. It's going to be very difficult to spot. These rough welds or rough parts of the system that are difficult to get to, difficult to clean, are like those mountainous areas. It's going to be easy for bacteria to hide and grow. So make sure that your entire plant is, as, if I can call it, as smooth as possible to stop the bacteria from adhering and growing in these sections. So any rough welds, rough joints, poorly maintained parts of the plant, swab these sections and then do the testing. Poor plant maintenance, again, look for damaged areas in the plant, and these may be in cracked tiles. We've swabbed cracks in the tiles, deep floor grouting, cracks in the walls, and found pathogens hiding in these areas, especially the floors, because they are wet and moist, often have dirt buildup, so they create the perfect environment for bacteria to grow in. Damaged conveyors, damaged pipes, seals, wherever there are taps, valves, these are areas that the seals can perish and become damaged and support bacterial growth. The next one is staff hygiene. Now, it may be tempting just to go in and just do some swabs on your staff's hands and they come back negative and you say, oh, well, no, it's not my staff, I don't have a problem. What I would recommend is actually going into the factory and observing the staff. So spending anywhere up to an hour possibly even more depending on your processes, and just watch the staff, see what are they doing. You know, are they dropping something onto the floor and picking it up? Are they scratching part of their body? What are they actually doing? Are they washing their hands properly? So watch them go through the hand washing basins. Are they scrubbing their boots properly? So again, you may have the correct processes and procedures in place when it comes to staff hygiene, but what are the staff actually doing? And the only way to find out what they're doing is to observe them. What you can also do in terms of swabbing is take random hand swabs. Remember, if you're looking for pathogens, you can swab staff members while they're busy working. Swab boot washers and brushes. So the equipment that the staff are using to clean themselves with their PPE may be a problem. I have swabbed and found listeria in a boot washing machine before, because the boot washing machine hasn't been subjected to a cleaning and sanitizing process itself. So it became a point of harboring the bacteria and allowing them to grow. So check all of your PPE, check your systems that are cleaning the staff, and watch your staff, see what they're doing. If your raw materials are suspected, testing the raw materials will be necessary. So raw materials in a process which do not make use of heat as a critical control point, such as salads, are obviously very important. If you have a heat-based or a CCP that does eliminate or reduce bacteria, it would usually be heat, then you have that CCP to try and rely on. But if you're making food that is not being heat treated, you don't have heat as a weapon against the bacteria. So it's very, very important to make sure that you are buying raw materials of a high standard, because whatever you put into that salad or that sandwich is ultimately what's going to go out, because you don't have the opportunity to kill the bacteria. So I would ensure that suppliers of food or raw materials to your business has a food safety system in place, and that they are also able to provide their own microbiological tests or evidence of their own microbiological tests, and that you engage with them to understand what are they doing and what systems do they have in place. Random testing of products will also give you comfort that the foods are of the correct quality. But again, if you have got a positive result, testing specific batches of raw materials that were used in that affected product will also help to either prove or to eliminate your raw materials as part of the problem. So once we've been through the entire process, we've had a look at everything from the receipt of the raw materials right through to the distribution of your final product and everything in between. We've checked your staff hygiene, we've checked the cleaning and sanitizing, we've had a look at all the CCPs, we've made sure that there's no failures, that there's no problems with the equipment, and we have now identified our problem. We need to make sure ultimately that this does not happen in the future. So how are we going to prevent this? So once we know what the cause of the positive result, we need to ensure that it never happens again. So if you've had a failure of a CCP, why did the CCP fail? And ensure that this reason is eliminated going forward. So if it's a failure of equipment, you may need to have another type of equipment or a better supplier of that equipment. If it's a thermometer that hasn't worked correctly, it may be you may need to calibrate your equipment more regularly. You may need to do verifications more regularly. So again, why did it fail? And put something in place to ensure that it doesn't fail again in the future. If your CCP has not been identified, obviously implement a new CCP and ensure that it is monitored. I think it is also important to understand why was the CCP missed in the first place. So maybe it's a way that that you're reviewing or having a look at your processes. But whatever the reason is, again, try and find out what that is. Is it a lack of education? Is it a lack of understanding what a CCP actually is? Find out what that is, and again, make sure that that doesn't happen again in the future. If it's poor handling after CCP, again, ensure that the foods are handled with the utmost care after the CCP to prevent contamination. And again, try and understand why was this problem not picked up in the first place. In your initial analysis of your systems, why wasn't that problem picked up in the first place? Because if we can understand why we're not picking up problems in the first place, whatever those problems may be, we're ultimately going to be able to understand and prevent them from happening in the future. If it's cleaning problems, again, a reputable chemical supplier, one that preferably has their own ISO standards in place and products registered with the NRCS is your first port of call. And again, make sure that you're getting the right advice, the right service from those chemical suppliers. They are ultimately the companies that are making the chemicals. They have made the chemicals for a specific reason, for a specific cleaning or sanitizing within a specific environment. And they are the ones that need to be guiding you in terms of what products that you need. I mean, ultimately, you'll need a detergent to remove the dirt, and you will then need a sanitizer to kill the bacteria afterwards. So those are your two most essential. But what types of detergents, what types of sanitizers would be best applied within your facility is going to be something that your chemical suppliers will be able to help you with. So if it's, again, cleaning problems, implement a true CIP. So we would recommend calling in a professional company that deals with the design and implementation of CIPs, and make sure that all areas of the plant that are not part of the true CIP are dismantled, scrubbed, and sanitized on a regular basis. This is very, very, very important because if there are sections of your plant that you are not getting to either with a CIP or a regular dismantling and cleaning, it is almost guaranteed that over time you're going to have a biofilm building up in those sections and causing problems down the line. So this is absolutely critical, and I've seen this in so many cases, anything from water bottling plants through to sauce plants, through to meat processors. Extremely important. I can't emphasize how important it is to make sure that you are accessing all your areas of your plant either via a true CIP or properly dismantling, cleaning, and sanitizing. In terms of poor plant design, obviously you may have to redesign or eliminate the poorly designed part of the plant. I was at a plant many years ago which had these trolleys which the food were placed on, and the bottom of the trolley had this expanded metal mesh. Now the mesh, extremely difficult to properly clean because there's just so many little nooks and crannies, and it turned out that this was one of the areas where the bacteria was breeding. So just by taking the mesh out and putting it a smooth stainless steel surface at the bottom of the trolley, that part of the problem was eliminated. So just make sure that the plant is properly designed, and if one thing you can take away from this is that you want it to be smooth as possible wherever the food touches. Again, any dead ends must be eliminated from the system. We don't want anywhere where food or water or any kind of liquid, solid can accumulate and spend extended periods of time because the bacteria are going to grow. Plant maintenance, that's obviously fix any of the damaged areas of the plant, especially cracks and damaged sections which could allow for the bacteria to grow. Poorly maintained parts of the plant that come in direct contact with the food are obviously the most critical, but like I've said, if you've got even chipped or cracked tiles where bacteria are growing and surviving, they're going to be picked up ultimately by the boots of the people and spread throughout the plant. Staff hygiene training is the big one there. Make sure that staff are trained and remind them until it becomes a habit. So don't think that you've trained the staff or told them what to do once and they're going to remember that forever going forward. It doesn't happen that way. You have to watch what the staff are doing. Don't walk through your plant with a blinker on like racehorses. Just walk through your plant. Make sure that your eyes are open to what's going on all the time. Watch the staff, see what they're doing. And if there's something that you identify and that's a problem, call them out. Say, guys, you can't do this. Please watch that. Don't touch this, whatever the case may be, and remind them until it becomes a habit. Obviously, the problem is raw materials. What you're going to do in the future is only use raw materials from companies who have a proper food safety management system in place, and that can also supply their own certificates of analysis for their food. So you need to be confident that your suppliers are providing you with the correct quality and a safe food. Lastly, I just want to talk about implementing a monitoring system, because as the saying goes, if we don't know that we've got a problem, we can't fix it. So your monitoring system a microbiological monitoring system in your plant is going to be there, and it's going to be designed to try and detect if there are any problems. So the program must be designed to find potential problems and not just try and give good results. Very often we see microbiological environmental swabbing programs or testing programs that are really kind of designed to try and show that the foods don't have any problems, rather than trying to uncover problems. And there is a fundamental difference. When trying to uncover a problem in the factory, we really need to go and look for it. So if you've got pathogens hiding in your factory, you really need to try and find them. You can't just pay lip service to environmental monitoring. So if you've got a salmonella or a listeria hiding in your factory, you need to be going and looking in those hard to reach areas, little nooks and crannies, and swabbing, and trying to find out where it is. You can't just be swabbing clean surfaces and easy to reach areas, taking 10 swabs and saying, you know what, they all come back negative, I don't have a problem in my factory. Because the problem may be in those hard to reach areas where you're not looking. So I'm just saying, make sure that you really design the system to try and detect the problems. Because if you don't know that you've got them, you're not going to be able to fix them. Remember also that swabbing for pathogens is a little bit different for swabbing to prove cleaning efficacy. So when you're trying to prove cleaning efficacy, you're going to clean down the area that you want to swab. Once it's been cleaned, you're then going to take a swab of a certain area. It's usually a 10 by 10, 10 centimeters by 10 centimeters. You would then do usually a total bacterial count, possibly even a yeast and mold, sometimes even an E. coli count, to prove that your cleaning and sanitizing has worked. When we're looking for pathogens, it's a little bit different. We don't have to limit ourselves to a 10 by 10 area. We really want to try and swab. We want to try and find this. So don't go and have a look and say, oh, do we have a listeria hiding in our drain? Don't just swab a little 10 by 10 area of the drain. Swab as much of the drain as possible. Take out the trap within the drain. Swab as deep down as you can. Remember, we're trying to detect the pathogen. We're not trying to determine counts per squared centimeter here. We really want to find, is there pathogens hiding in that drain? Or if you've got a particular machine that you're worried about, try and swab as much of the area in question as possible to try and find if we can detect this pathogen. You may also want to swab during production, because remember, if you've got a production line, especially after a CCP, if you're looking for pathogens, swab during production. Don't be scared to do that, because during the production process, there shouldn't be those pathogens present anyway. Obviously, we're not going to do total bacterial counts, because general bacteria from the products may be resulting in these high counts. But when we want to find pathogens, make sure that you have a different mindset to trying to find them. Also, when trying to find pathogens, make sure that you use detection methods in the laboratory. So when you send your test off to the lab, when you're looking for pathogens such as salmonella or listeria, use a detection method. The detection method is far more sensitive than the enumeration method and can detect pathogens at very low levels in swabs or in foods. So we often find factories that have got an environmental monitoring system, or they've got a food testing system in place, and it's coming back with a negative result all the time. We have a look at what types of tests are being done, and it may be an enumeration method that is not sensitive enough to pick up low levels of the pathogen. So yeah, very important to try and use your detection methods for pathogens. And then also implement an effective food testing program. So again, you don't need to test every single product that comes out of your factory, because you won't have anything left to sell. But according to the risk of the product and your factory, get an effective food testing program together, where you're testing some of your raw materials, testing in processed foods, testing final products, doing environmental swabs, again, proving efficacy, trying to look for pathogens, testing your water, taking hand swabs. This is going to give you information over time as to what is going on in your factory. And it will also be an early warning system to provide you with information that there are potentially problems occurring in your factory. And the last thing is obviously to use a SANIS accredited laboratory for all your microbiological tests. A SANIS accredited laboratory will ensure that the correct methods are being used and that you have accurate results that are being displayed to you. All right, and I think that brings me to the end of my presentation. And again, just to say thank you very much for the opportunity. Over to you.
Great. Thank you, Shane. That was really a very, very comprehensive approach. And I think you've given us some very, very practical points that we should consider. I've got a few questions, if you don't mind, that I'm going to throw at you.
Sure.
And if we haven't got all the answers, we can make sure that we put them into the follow-up article. Going back to the very first slide, you mentioned that I should be, when it comes to what is a positive result, it means that I haven't met the specifications.
Yes.
We often get inquiries as to where can I find some reference point for specifications. In your experience, what would be your go-to? You did mention Codex, but if you have to assist a client in putting together a program, have you got some secret sources that you could kind of like share with us, in terms of where you would be considering, or what you would be considering as specs?
Okay, so we did that article a couple of months ago with regards to, again, microbiological testing programs. And I did provide a few references there, so we can go and get those and post them. But I think, to start off with, you want to make sure that you have your legal specifications. Google's always a good way to go there. There is a link to the site which we can provide. It is a little bit difficult to navigate in my experience, because very often there's different departments that you need to run through. But understanding and making sure that you comply to the legal specifications in South Africa is first and foremost. Codex is always a good one for me to have a look at, to make sure that we are complying to internationally recommended specifications. And then again, even whoever you're using for microbiological testing, ask them. They've usually got a wealth of knowledge. I mean, we've built up a lot of experience over the years, and we can often provide guidance on specific products and what the specification should be.
When I look at the approach to sort of troubleshooting, one of the questions I wanted to ask you was, if you had to be called in to help me with this problem, how, or put it this way, in my experience, I find people go through a process of elimination almost in a stepwise approach, as opposed to doing a multi-pronged root cause analysis investigation. So, my point being is that if I first investigate the cleaning chemicals, and after that there's nothing wrong, and then look at maintenance, and then look at personal hygiene, if I stretch out the process too long, often the micro results almost become out of context. So would you look at a multi-pronged approach? We simultaneously look at cleaning and maintenance and in order to make sure that we can get through this process as quickly as possible, because with short shelf life products, we obviously are running against the clock in all cases.
Yes, absolutely. I mean, I think the more areas that you can try and attack at once, the better for it. So, and again, like you said, it needs to happen as quickly as possible, but also understanding that some of the processes may take additional time to have a look at. But yeah, I think the important thing is to try and cover all of your bases. But you are 100% correct. And don't focus on one, wait until that's resolved to move on to the next. I agree with you 100%. A multi-pronged approach is the best.
And also, I think what's important is keeping a record of what you have checked, because the next time you have a similar problem, you really don't want to keep going around and around in circles. If you've got, a proper report that you complete after this situation, at least then you've got a good reference point for the next, possible positive.
Absolutely, yeah. I think important to keep track of trends. So, as I've said, with that environmental monitoring program that you put into place, and a proper microbiological testing program that you put in place for your final products and even in-process products, is to continuously monitor those results. And if you are getting indications that there may be problems, even if they are just slight or any kind of trends that are differing from the norm, it's important to try and investigate those as soon as possible and keep track of those trends. Why is this happening? Why are we picking up generally higher counts in this area of the factory or in this particular product? What's going on? So yes, trend analysis and keeping track of everything, agreed, very, very important. And investigate as soon as you see that there's something that could be going wrong. Don't just say, it could be because of this, or I'm sure it was just a one-off. It's important to try and make sure that we attend to any potential problems as soon as possible before they grow into bigger problems.
Yeah, because like you say, I think the operative word there is grow, because, you know, while we're ignoring them, they're just multiplying. So, you know, when it gets to the point that it's a really big problem, it is a really big problem. The other thing I wanted to just chat to you about was when it comes to, I mean, you've obviously had a lot of experience with what I thought was a CIP system, only to discover it's just rinsing through with cleaning chemicals.
Yes, yes.
How, you know, in terms of your involvement with the validation of CIP systems, I definitely think that's an area where the microbiologist should be involved, because we should actually be validating those CIP systems on a regular basis.
Absolutely. Look, that can also form part of your environmental monitoring program. So you would be swabbing areas that are CIP'd to make sure that you don't have biofilms building up and any problems. But yes, for me, that's probably one of the biggest problems that I've encountered in the food industry, is that people think they've got a CIP system in place where they actually don't. So it's very important to make sure that you actually do have a proper CIP system in place. And the way that the CIP system works is that it will close off with a valve on the one end, they'll close off on a valve on the other end, and it will have a loop system that you can pump through these chemicals at very high pressure and high temperature. The pressure is very important because it loosens the biofilms and it gets rid of the dirt. If you don't have the pressure, it makes it easier for these biofilms to cling to the system and then to grow. So a true CIP system has to have that pressure and the temperature and obviously the correct chemicals. If you're not having that loop through and that circular system where you're literally rinsing through at high speeds and high pressure, it's not a true CIP system. And what I've also experienced is sometimes you have a production part of the plant where they cooking and processing the foods, and it then goes to a packaging part of the plant. And in between, so you've got two true CIP systems, but there's a short space in between where these two systems basically don't meet. And you've got a valve or a section of pipe or an area where there isn't a proper CIP system. It's not reaching because you've got these two separate systems. So that can also be a problem as well. So it's very important to make sure that you have a look at your entire system and make sure that you do have that CIP. And if you don't, you have to. I know it's a mission, and people say, you want me to take all these pipes apart and clean them, you know, every 2 weeks or every month or whatever? Yes, if you don't want your products blowing, if you don't want contamination, you're going to have to do that. And in my experience, in every single case that this has happened, once they've done that, their problem has disappeared.
Yeah, absolutely. The other thing I just wanted to point out, and I'm sure that I'm sort of stating the obvious here, but that is the point, is you can't only do this troubleshooting in the lab, you actually are in the factory for troubleshooting, Shane? Am I right?
Absolutely, absolutely. It's hands-on, it's getting down and understanding. I mean, I've been to factories as well where people have called me in after pulling their hair out. They said they've had all these experts in, you know, ISO and BRC and so on and so forth. And, you know, they've checked all the paperwork, and, you know, I've rocked up and I said, here's all the paperwork for you. I said, look, you know, I don't necessarily need to see this paperwork. Let's go and start in the factory. And, you know, we spent a day in the factory, and then we've seen some horrible things happening. So yeah, important to make sure that you're in the factory and it's hands-on.
Absolutely. I think this is definitely an area where I've seen where the microbiologists, you know, or the in-house person is not tackling the right approach. We really need to get into the factory, because it's only then that you see that the pipe is not smooth, or you actually see that something is leaking. Okay, I've got an interesting question here, and I think this is something that we often struggle with. Is Joy has had a problem where she's been testing. She's had an E. coli positive product. She's tested the product again. She's tested everything she possibly can, but everything has come back negative. She's tested in the plant. She's tested raw materials. So she's run up quite a bill here, but she's still not finding a reason, or put it this way, she everything's coming back negative, the same products, and it's how do we close a non-conformance, or how do we fix a problem when we can't always find the root cause of the problem? Have you had situations like this?
Well, yes, I think that does sometimes happen. It could have been a sporadic once-off issue. I mean, it could be a case of a staff member on that day not washing their hands correctly, touching the product, and you happen to test that product or test that batch that's been affected. That doesn't happen again. It's a one-off problem. So yes, it can happen. It can happen that is the case. So again, I think do your due diligence, run through the process, make sure that everything's working, your CCPs, everything's done, your cleaning chemicals, double check everything, make sure that you're comfortable with all that, do some additional testing. But again, also be careful not to overdo the testing either. Make sure that it's focused and it's meaningful. And yeah, I think from then on, if you're satisfied that you have done your due diligence, you've checked everything, you're going to have to rely on your results going forward. You may want to possibly test a little bit more frequently. If you're testing one every 10 batches, maybe you want to test one every 5 batches for the next month, just to make sure that you're not picking up the same problem and that it has gone away, and then continue on along your regular testing program, and just make sure that you're observing those results regularly. So it can happen that way, Linda. Yeah, absolutely. Sometimes it's impossible to find, especially if it is a one-off problem. If it is an inherent issue, you usually will end up finding it.
Yeah, and I think, I mean, if I had to now ask you to be an auditor instead of a microbiologist, but a competent microbiologist auditing another microbiologist, you would be wanting to make sure that I followed a robust process to identify the potential cause of this problem. And if you can see that I followed that process and I have all that evidence, but I haven't been able to find the specific reason for the contamination in this batch, I've still followed the right process, and that's, I think, what it's really about.
Absolutely, that is it. And like I said in the presentation as well, I think it's also a good idea to possibly call out an external consultant to come and bring a fresh pair of eyes, because very often it is factory blindness. You're just not seeing the problem. It's glaringly obvious, but you're not seeing the problem. So I've been into many factories where I've had very, very senior people, very, very experienced people working, and it's just been a very, very simple solution. It's been a cross contamination after a CCP, and they're just like, but why? I mean, we've had this entire system installed. It's cost millions of rands. We've got this massive company to install the whole thing. We've got qualified people, but it's a slip. It's a mistake that no one has seen, because everybody's working with the system every single day. So yeah, an external pair of eyes, in my experience, can help to identify a problem that maybe you think is impossible to identify.
Cool. Well, Shane, we've run out of time, but I think we could probably carry on for a little longer. And I think definitely something that might be interesting for us to chat about the next time is looking at microorganisms in dry products, because I think, as Joy has mentioned in her example, often we can have a misconception that, well, it's dry, so it's not going to be a problem with regards to microbiological contamination. But I think there have been a number of very interesting recalls, E. coli 0157 in flour, all sorts of things that that put a spin on dry products, and perhaps we can chat about that the next time. I just want to say thank you so much. It's been very, very informative. I really appreciate it. Everyone has stayed to the end, which is amazing. Thank you so much for being with us. Don't forget, everyone, that the recording will be posted. So if you want to refresh it and go through it or share it with your colleagues, you can look out for that email, and we'll definitely convert this into an article as well, so that you can touch base with that, and we'll add the link to Shane's previous article to help you to find specifications for microbiological testing as a link, so that you've got that one as well. Everyone, have a great Thursday. Shane, thank you so much, and we look forward to chatting to you again.
Fantastic. Thank you very much, Linda, and thanks to everybody that dialed in. Appreciate it, and hope that you have gained some good knowledge out of it. Thank you.
Great. Bye.
Okay, bye.